Good morning, everyone. Myself, Dr. N. Inspect Sunil from Sage Institute of Technology. Today, we are going to study about the stability of the system. The stability of any system is very important. It may be mechanical system or electrical or physiological system. What is stability? A system is stable for a bounded input. The output should be stable. Then only the system is said to be a stable system. There are three types of system based on the stability, that is stable system, unstable system and a marginally stable system. What is stable system? A system is said to be a stable system for a bounded input. The response of the system is bounded. Suppose in a stable system the input is absence, the system approaches to the output approaches to zero as a time approaches infinity irrespective of the initial condition. But in an unstable system, the system is said to be unstable. For a bounded input, the system produces an output which goes on increasing without any bounds, and a designer has no control over it. For marginally stable system, if the output of the system does not go down to zero or go increasing. Then Raoult-Curville stability criterion, this is the very basic approach, simple approach for finding the stability of the system in time domain. Using this method, we can tell how many closed loop system poles are in the right half of S plane and the left half of S plane and on the imaginary axis. Based on the poles of S plane, the system may be characteristic to stable system or unstable system or marginally stable system. The main limitation of this Raoult stability criterion is we cannot find the exact location of the poles. We can show only the poles, how many poles located on the right half of S plane, how many poles located on the left half of S plane and on the imaginary axis. Let us see, this is the nth order continuous system characteristic equation. Now the first step is we have to construct the Raoult array. Then second step is from the analysis of first column of Raoult array, all the elements should be positive. Then the system is said to be a stable system. Suppose in the first column of Raoult array any sign changes occurs, there are poles on the right half of S plane, then the system is said to be an unstable system. For example, this is one basic transfer function. This is A4 into S power 4 plus A3 S power 3 plus A2 S power 2 plus A1 S plus A0 equal to 0. This is a characteristic equation of this system. Now construct the Raoult array. The highest degree of the polynomial is S power 4. We can write the Raoult array matrix S power 4 and S power 3. These two rows are filled from the characteristic equation. Then other values S power 2, S power 1 and S power 2, 0. These values are calculated from the above two rows. For S power 2, the first value is the negative determinant of these two cross 2 matrix divided by the leftmost corner value A3. This is the value of this first value. Then second value, second column, the value is minus into determinant of this column and this column. These 2 cross 2 matrix, the determinant of these 2 cross 2 matrix divided by this value A3. From this method, we can find out all the values in the Raoult array. Then we can see about we can see about from the first column of route array, there is any no sign changes, then the system is unstable. For example, this is one problem. The g of s is 7 divided by s into s plus 1 into s plus 2. This is the open loop transfer function. From this open loop transfer function, we have find out the characteristic equation. The characteristic equation is 1 plus g of s into h of s equal to 0. We can find out the characteristic equation s power 3 plus 3 into s square plus 2s plus 7 equal to 0. Now we can construct the route array for this characteristic equation. For this characteristic equation, S3 and S4, S2, these two rows are constructed from the coefficient of this characteristic equation. Then S power 1 and S power 2, these rows are calculated from the above rows. Now we can see this first column of route array, there is one negative value. Okay, one negative value. Now find out the number of sign changes in the route array, the first column of route array. Let us see, from this 1, 3, there is no sign change. Then 3 to minus 1 by 7, there is one sign change. Sign is plus 2 minus. Sign changes from plus to minus. Then minus 2 plus. Okay, so there are two sign changes occurs in the first column of route array. So there are two roots are lying on the right half of S plane and remaining roots are lying on the left half of S plane. So the system is unstable. Then let us see the next problem. Here this is a characteristic equation, s power 3 plus 3s square plus 2s plus 3 is equal to 0. Now let us construct the route array. Here in the first column of route array, there are no sign changes. There are no sign changes means all the elements are positive. Here all the roots are lying on the left half of S plane. So the system is stable. Then consider this problem. The characteristic equation s power 5 plus s power 4 plus 2s cube plus 2s square plus 3s plus 5 equal to 0. Here in the s power 3 row, first element is 0. The first element is 0 in a row. We can find, we can take the value a small positive integer epsilon. With this epsilon, we can construct all other rows in the route array. Then after completing this, we can substitute the epsilon tends to 0 limit. The value epsilon is 0. Then we can find out the first column of route array. If there is any sign changes, the system is unstable. Let us see here. The first this row s power 2. S power 3 is this epsilon tends to 0, this value is 0. In the next row, 2 epsilon plus 2 divided by epsilon. Now letting the epsilon tends to 0, then this value is infinity. Then the next s power 1, we have to substitute the epsilon tends to 0, then the value is minus 2. Then there is a sign change. There are two sign changes. The s power 1 value is negative, then there are two sign changes. S power 2 to s power 1, one sign change. Then s power 1 to s power 0, another sign change. There are two sign changes. So two roots are lying on the right half of S plane. Hence the system is unstable. Okay. Thank you.